All right. Good evening, Warriors. I hope you are well. It's good to see y'all. We will get started. We are recording right now, so we'll get on with the main attraction for this evening. You're looking at the map check, and we will begin with that. Hope you are all well. Let's get down to it. So today, 23rd of April, tonight we're going to be going over population mean, where the sigma is unknown, and this will be the last batch of hypothesis testing that we do in this format. Looking ahead to Sunday, we've got 3 homework assignments in Pearson due. That's a total of 6 problems. That's 3A, 3 Bravo, 3 Charlie, due by 11:59 on Sunday. Again, that's all on Pearson. Looking ahead to next week, we're going to have on Tuesday, we're going to talk about regression. And let me see here. I left some stuff off. Let's just slap this stuff in here while we're there. All right. So looking ahead to Tuesday, we'll have Zoom. We'll do regression. And then also on Tuesday, I don't have that in here either. I'll post a regression assignment, and that'll be on Canvas. So that'll be the only assignment that you perform and then submit that's outside of Pearson. Okay. That'll appear Tuesday. It'll be due not this coming Sunday, but the next Sunday. And it'll be pretty straightforward. By the time we're done on Tuesday, you should be able to rock that out. Past Warriors have not. That's been one of the more straightforward things we've done really to date. So, and then the week after next, we'll spend all week prepping. The 2 sessions that we have, we'll have Zoom sessions there as well. We'll get after hypothesis testing. We'll get some reps in on regression. We'll even get some reps in on descriptive statistics, all towards preparing for the final, which will be the 14th of May. And then also on the 8th of May, that's when I'll complete your classroom interaction and participation assessments so that you'll have all the information to understand where you stand in this course about a week out, a little bit less, 6 days going into the final. Any questions on the map check? Okay, driving on. So here's what we're going to do tonight. The recording is going on. I just want to talk very briefly about class interaction and participation standards. And I just want to say it, be done with it, and move on. So 50 points of this course is my assessment of your interaction and participation to date. I had one model that worked, or at least that was the framework for when we were resident. Obviously, things have changed. We've been online, and so things have changed. I've talked about this in writing. I just want to talk about it one last time. Okay. All right, Chastity, I appreciate that. I just want to talk about this one last time, and not again. So, and I don't like talking about it because I don't like talking about what quote I expect, because to me, this is team ball. It should be expectations that we have of each other in order to get the most out of the class. But obviously, you have to come to class to participate in class. That's kind of the first order of business. The second order of business is being up and present when you're in class. So to me, that means, like many of you are doing tonight, which I think is great, that means your video is up. I can see you, that you're engaged. I'm not looking at a black screen or some kind of static image, which doesn't really tell me if you're away from the keyboard or not. And again, I've said this before, so I'm really not going to go on and on with about it. If you have or are experiencing audio or visual difficulties, like Chastity just texted on the message, then let me know and let us know. I don't expect everybody to have flawless communications all the time. I certainly don't expect folks to run out and buy capabilities that they don't already have, like webcams and stuff like that. Some of you have talked to me about this prior to tonight. And that's the only thing I ask is, hey, if you've got something, that's hindering your ability, then just let me know. And I'll probably be okay with that. Um, what what kind of when we don't have that communications, I just kind of I'm like everyone else. I just kind of start going to assumptions that may not be accurate. If I have the time, I might reach out to you and say, "Hey, what's up with this?" But at this point, I mean, it's kind of all of our responsibility. So if there's some reason, whether it's permanent or on a case by case basis, why you can't meet these expectations, you can't turn on your video or you can't turn on your audio, you can't answer when you're called upon, these types of things, I just ask that you let me know. Otherwise, I'm just going to I might fall to assumptions. That's not a threat. I'm not trying to be passive. I'm just trying to tell you, communicate where I'm at and trying to assess these points that arguably could be very, very easy points for everyone. Okay, so that's the end of that. I don't really want to talk about it anymore, but if you do want to discuss it, then I want to as well. And we can do that outside of this class through email, through other means of communication, if you've got something you want to talk about. And again, I don't mean that passively. I mean it quite the opposite, because if there's something you have going on and something that would I need to know about and to understand more, then please, I look forward to that understanding. Enough said on that. So tonight we're going to play the frame game, Bravo, real quick. And then we're going to cover the last contingency situation on hypothesis testing, which again is a situation where we have a mean, but we do not know the population standard deviation. And so just to bring us into this slide we've seen twice before. This is our third time looking at it. This is where our yellow box is kind of where we are in the grand scheme of things. In the Disneyland, in the shopping mall, whatever. Prior to this session, Tuesday, we spent up here on population mean, where we do know the standard deviation. And last week, we talked about population proportions. So tonight, again, we're going to talk about population means, where the standard deviation is not known. And again, this all boils down essentially to 12 ways that we could twist situations and problems. Again, 12 is not 6, it's not 3, but at the same time, 12 is not 244. So again, I encourage you to use these slides as an assessment of, do I understand the lay of the land, and what is my strength or challenge with any one of these big buckets here? If we drill into this yellow like we had before, we will find that the characteristic of this type of situation, when we have the population mean, but we do not know the standard deviation, we no longer are going to use the z-stat or the z-distribution. Instead, we're going to use the t-stat and the t-distribution. And there's some nuances that come with that. There's a little bit of things that we've got to do right, some details that we've got to pay attention to. But once we pay attention to those details, there's a lot of commonality between what we've learned so far. So that's the big picture. That's what we're going to do tonight. To get a little bit warmed up, we're going to do a frame game. So once again, the point here on a frame game is to just get our mind warmed up. We're going to go over two things, but first, a little bit of motivation by one of the classicists in total quality management and D3M itself. Dr. Deming actually worked for Eisenhower during the Second World War. So in terms of badasses in the field, he's definitely up there. This quote I ran across today, and I just thought it was pretty motivational. And why is it motivational? Because for you, after this class, even right now that you've been through the Way of the Warrior project, you've been in this class for a while, you are not just another person. You now have mad skills that you can be a person beyond an opinion. And so you can engage in arguments and discussions beyond emotion. You can bring logic and science to the table. And I think this is really cool. And I also think this is kind of a dividing line between professionals and amateurs, because people who have discussions that are charged with emotion, they are a dime a dozen. But what we really need in the market is people like you who can say, hey, let's put emotion to the side for a second and let's bring in some numbers and just a little bit of logic. And I will tell you, once you establish yourself as one of those types of people, you will be invaluable. People will not want to have meetings without you in the room. That is what you have to look forward to. And I look forward to you being that person. So on with that, let's get started with a little bit of frame game Bravo time. The two things we want to do tonight, we want to, with each one of these, we've got 3 simple problems just to get warmed up. We want to identify the null and the alternative hypothesis. That's the number one thing we want to do. And we want to talk a little bit of, if we reject or fail to reject in context with the problem, what might be a next action we would take. Okay, so we want to focus on those 2 types of things. And here we go. So let's check it out. Let me get my pen fired up. All right, here we go. Emma is convinced that the bus that travels from east to west campus, you know, that little white bus, there's a bunch of them with the Spartan on the side, needs a beard, too clean shaven. But anyway, that bus that travels from east to west campus, she thinks it's taking longer than it normally does. Before, in the past, when she missed a bus, so she'd be coming out of, what is that, Campbell, and she'd see the bus just leaving. So before, when that happened, she only had to wait 10 more minutes before another bus would come by. But now she feels like she's got to wait longer. All right. And she feels like if she has sufficient data, she might file a complaint about this. Okay. But being a D3M warrior, she first, in order to have credibility, knows that she's got to do a hypothesis test. All right. So let's jump into the action. Travis, what do you think is the null here with this situation? Travis, you out there?
Yeah, I'm having a really tough time with my internet right now.
Okay.
Let's just hope it's okay for the rest of the class.
Okay. That makes 2 of us. All right. So what do you think? I can hear you great. What do you think we have going on for a null?
Would it be the population mean?
Okay. All right. And what about the population mean?
Would it be equals 10 minutes or equals 10? No.
Okay. Nick, what do you think?
I was going to say it's less than or equal to 10 if it's taking longer.
Okay. So less than, so you want this up here?
Yeah. And then
And what would go down here?
Greater than.
Okay. So this is the correct setup. All right. Emma believes that it's taking longer than 10. So anything that even looks like that becomes her alternative hypothesis. But first, she's got to disprove the null or reject the null. Okay, so this is a good setup right here. So, Cameron, if she does this hypothesis test and ends up rejecting this null, what might be the next thing she would do?
If she rejects it, that means she can file the complaint because it's taking longer than 10 minutes.
Yeah. She can file that complaint with credibility. She can walk into whatever the director of campus operations and say, hey, man, I dropped some science with defiance here. I took a sample of this much. I did a hypothesis test. Because I wanted to make sure that I wasn't making a mistake, I used a really low level of significance of alpha 0.01. And check it out, I still rejected the null hypothesis. So what are we going to do about this? Man, what a scene that would be. I'd like to be there when that happens, you know, just to mess it up, right? But that's very simple. Okay, so good job on that one. Let's go on to one that's a little bit harder. These get harder along the way. All right, first let me get rid of this annoying box. Okay, here we go. Walter is on trial for producing meth. Okay. So the DEA has seized a major meth lab. Let me get this out of the way. In order for the prosecution to have a strong case, Walter's fingerprints must be a 51% or greater match with the fingerprints found on the meth lab equipment. All right, so I'll draw you a little kind of amateur diagram. The DEA has seized this meth lab and there's fingerprints everywhere. Okay? And they're not going to be able to count every single fingerprint. Okay? But in order for the DEA to have a strong case against Walter, they've got to have 51% or greater of a fingerprint match between Walter's fingerprints and the fingerprints found at the crime scene. We got beakers, we got big vats of stuff, we got all sorts of equipment in there. So Hank's been around before. He's the DEA agent leading the investigation. To have an unbiased approach, what would his null and alternative hypotheses be? So, Tim, what do you think is Hank's null hypothesis?
You hear me?
I can hear you now.
Okay. So it'd be the P-pop, and then it would be. This one gonna be. I know the number is 51,
Okay.
and is it gonna be greater than or equal to in the middle?
Right here.
Yeah.
So we're close. What do you think, Matt? What do you think goes up here?
Less than or equal to,
Why do you think that?
because it's asking for or it's coming from the side of the prosecution.
Yeah, so say that in another way, like a plain or English way.
Oh yeah, it's has to be unbiased. I see.
So if we had the opposite here, we would be saying, again, remember the null is associated with status quo. And so if this was P-pop is greater than or equal to 0.51, essentially we're saying from Jump Street that Walter did it. And our case is going to get thrown out. So we actually have to reject the idea that we first have to reject that Walter's fingerprints are not on a preponderance of the equipment in the scene. So this becomes that. So we have to reject this the opposite of what we believe in order to have support of what we believe. Okay? So this one a little bit tougher here. All right. And I think what Matt was getting after, not to speak for him, is we first have to reject the idea that he is innocent before we begin to explore that he is guilty. Is that accurate, Matt? Yep. Okay. All right. Now the toughest one, potentially, I don't know. All right. So Helen and Cindy want to sell hot dogs at the hockey game. They think that more than 55% of people prefer hot dogs over hamburgers at the local hockey rink. So they have this idea that if they can, get some traction behind this idea, maybe they can compete for a contract to sell hot dogs at the rink, something like that. So they go and ask Sloppy Joe. Sloppy Joe is the concessions manager at the rink, about what does he think in terms of people's preference of hot dogs versus hamburgers. And Joe says, I don't know, but it can't be more than 40% of people, 47% of people that prefer their hot dogs. Okay. So Cindy and Helen, being D3M Warriors, they're like, okay, we're going to get some sample data. We're going to do a hypothesis test. Based on that hypothesis test, we'll see if, we've got grounds to pursue this further. All right. So, Carrie, what do you think? What do you think the null hypothesis would be here?
Sorry, my mute was on. Okay, would it be P-pop is greater than or equal to the 55?
Okay. You see, so you think so the challenge, we have a couple numbers here. All right. What do you think, Anna Grace? What do you think that null might be?
That's what I was just trying to figure out. I don't really know, like, how do you tell the difference of which number to use when you're given two of them like that?
Okay. So this is the number that Helen and Cindy think is happening. Okay.
Mm-hmm.
But to avoid bias, they've got to put that aside just yet. Okay. Because they first have to reject the status quo. So this is very important. This is why I set it up this way, is because you've got to think about what number is most connected to the status quo. So this number here is more connected to the status quo because this guy is the guy who works there, and he's somewhat, of someone who has an opinion on the problem. He very well may be wrong, and we kind of hope that he is wrong so that they can drive on with this. Okay? So the number that needs to go up here and down here is that one. Okay? This one just kind of needs to be to the side for a second. All right? So
Okay. Yeah, I just wasn't sure, like, if you were supposed to use both of the numbers, like one in the first hypothesis and one in the second one.
yeah. So does this make sense now?
Yeah, definitely.
And this brings up a good point. That's why we do this, is because I want to get after those kind of issues, because from my brief experience, I've seen Warriors want to use both numbers. And so what we're trying to get reps on is how to pick the right number, and get comfortable that we're going to use the same number in both. And the only difference here is going to be symbology in between. So Alexis, with my null, what kind of symbol should I have right here?
Would it be greater than or equal to?
Okay, so let's see here. Joe thinks it can't be.
It can't be more than. Oh, so then it'd be less than
Yep.
equal to.
Okay. And of course, this has no equal to. So right here, this is the correct setup. Okay. So let's read it. P-pop is less than or equal to 47%. That's Joe's statement about the status quo. That's what we have to reject or fail to reject. And so if we reject it, then it would be that the alternative is supported, which would be that it's not less than or equal to, that it's greater than 47. And again, you might be saying, well, where's that 55 go? Well, again, that kind of goes to the side now. If we reject it, then it may be 48, it may be 49. But this first step in hypothesis testing is that we reject or fail to reject. Because if we fail to reject, you know, this belief kind of becomes null and void. It kind of just goes away. We may still have the belief, but we really shouldn't be doing anything with it because we just disproved a hypothesis test. So where'd my stuff go? So let's see here. Lauren, if we end up rejecting this null hypothesis, what might be an action that Helen and Cindy do next? So let's say they do the, go ahead.
Does that mean it's more than 47%?
Yeah.
So then it'll be more people who want hot dogs and hamburgers.
Yeah. And so they would compete for the hot dog contract because they would say, hey, look, the status quo is probably changed. There's probably a lot more people out there who are interested in hot dogs. Hey, you need hot dogs down here. We'll sell them for whatever. We'll do a big promotion, blah, blah, blah. But conversely, if they fail to reject, then they're kind of back to the drawing board kind of thing. See what I mean? Because the status quo is that, hey, not that many people prefer hot dogs over hamburgers, and that's why we don't have them down here at the hockey rink. Okay? Questions from anyone on what we just did, the frame game? Okay. With that, we'll get into the meat and potatoes of tonight, which is not that right there, but here we go. Hypothesis testing with the population mean and sigma is unknown. This is actually the Bermuda Triangle. I grew up like watching shows way back in the day anyway that talked about Bermuda Triangle and Easter Island and all this stuff. There's a show called In Search of with Leonard Nimoy. Yeah, the guy Spock from Star Trek. I'm not a Star Trek guy. Anyway, it was kind of a cool show as a kid. All right, so here's our hit list for tonight. The bottom line in this situation is we're going to be rolling with the T distribution. Okay, so right off the bat, you definitely want to imprint that in your brain. If I recognize the situation, there is no standard deviation for the population. I'm going to be working with the T distribution. Okay, So you really want to get comfortable with that. So here's our situation up front. You are the accountant for Jimmy's Waste Management Company. All right. You haven't been there that long, but during the time that you've been there, you've done kind of a quick review of files and transactions, and you believe that the sales department has been overcharging customers within the last several months. But the problem is there's a lot of records, and you don't have time to do a full audit over all those records to be sure. Okay. But you can do some sampling and do a hypothesis test. So the question you are pursuing in broad brush is the sales department overcharging customers? Now, before we begin, I think we all know by now that the common sense method, or just common sense, would tell us, hey, let's just go straight to a one-tailed hypothesis test. Either we're charging customers what they should be charged or less on average, or we're charging them more. And that would be a one-tailed test. So in reality, we would go to that first. That would make the most sense. But for practice purpose, we're going to start out first with a two-tailed test. Okay. So here's what we got. We've got the same problem. We've got a little bit more data. Let's check it out here. Let me get rid of all that. Okay, so we know that we're going to start out with a population mean sigma unknown. All right, so let's read again. You're the accountant for Jimmy's Waste Service. You suspect the average amount per sales order has changed from 120 per order. Okay, remember that has changed is key language. All right. This isn't saying that it's gotten more or gotten less. All right. Just key in on that has changed. Another way of saying has changed is saying it no longer is 120. Kind of that it is or it isn't kind of thing. You don't have time to audit all the records, but you do have access to a few. You select a sample of 12 orders from the last 6 weeks. Here they are. One order was 108.98, one was 152, so on and so forth. Okay? And you decide to use a level of 0.05 level of significance. All right. Our steps for critical value are the same. We're going to start out doing this as a critical value. So, Connor, what do you think our null hypothesis is?
Would it be that the mean is equal to 120?
It would be. Okay. And if that is correct, which it is, then Delaney, what would our null be?
And then it's going to be mean is not equal to 120.
Okay. Outstanding. All right. Again, so this is a correct setup. When we see that equals and a not equals, this to reinforce is kind of like saying it is or it isn't. It is or it isn't. And this symbology makes this a two-tailed test. So all these things go hand in hand. Has changed is a way of saying it is or it isn't. This symbology is a way of saying it is or it isn't. And anytime we say it is or it isn't, it's a two-tailed test. We're not saying it's increased or it's decreased because that language would be a one-tail. All right, cool. Moving on. Step 2, level of significance. We have our alpha right there, 0.05. And our sample size. So Carrie, what's our sample size?
12.
That is correct. Okay. All right. So step 2 is complete. Moving right along. Determine the appropriate test statistic and sampling distribution. Okay. And this is where it's very important. I told you there's no standard deviation for the population, but let's just revisit that. It isn't there. You are the accountant for Jimmy's Waste Service. You suspect the average amount of sales order has changed from 120. We've correctly identified that as a population mean. But in this little box here and nothing up here, there's no sigma. There's no sigma up here. Can't find it. Okay. If this was a piece of paper, we'd shake it as hard as we could. Sigma still wouldn't fall out. Okay. So one of the biggest telltale ways is if it's not given to you, it's not there. When we recognize this situation where we have sigma unknown, we are going to be rolling with the T distribution. Okay. And whenever we're rolling with the T distribution, our test statistic will be the T stat. Now, let's get that formula up here for what the T stat is. And remember, it's okay if you don't know. But let's just take a guess. I'll give you a hint. The T stat formula is one that we've seen before. So, Tim, you got any guesses of what might be in the numerator?
I can guess the denominator.
You want to guess the denominator? Go for it.
Does it have the sample size in it? The population, I mean.
It has a
Square root of it,
sample
yeah.
size in it. I thought this is what you're saying, so I wrote it in.
Yeah,
What do you-
pretty much.
What is that S?
We'll go. Is that the number? Because that's 12. Is it the time frame? We have 6 weeks there. I don't know if that has any impact.
You're in the right ballpark, but that's not that. Let me just write in the top here. Okay, some old friends. So, Cameron, what is this S? What do you think?
The level of significance.
Well, that would be alpha.
And
Okay.
I do not know.
Okay, that's all right to not know. Jenna, what do you think that S is?
Because you're using like the T distribution, would it have something? I don't know if I'm right, but you know how you use like the degrees of freedom with like the T table before? Is that somehow incorporated? Maybe.
Yeah, you guys are all thinking in the right direction. And the reason I'm asking you this is just keep that brain working and critical thinking. So this is the sample standard deviation. Okay, remember we have sigma, and sigma's little cousin is S, which is the sample standard deviation. That is the standard deviation of these 12 numbers right here. Okay, everybody tracking on what that is? Remember now? Colin, we good? Colin's like all day long, brother. Bring it. All right. So this is our T stat, and that's step number 3. All right, we're going to talk some more in a second and refresh on how to figure out how to come up with S. Okay, so I'll come back to that. Don't worry. All right, step number 4. We're on some familiar ground here. Step number 4 is determine the critical value rejection and non-rejection regions. All right, first things first, I'm going to do the easy stuff, the rejection and the non-rejection regions. Because this is a two-tailed test, my setup is going to look like it does on a two-tailed test, where I'm going to have a rejection region out here. Someone in the distance is crying. I can hear it, getting rejected. I'm going to have a rejection region out here. Same, boo-hoo. All right, my mean's going to be somewhere in the middle. And this white space is my do not reject region. Okay? This is all familiar. What's a little bit of a twist, remember the third part of this, in order to define this black area here and this black area, I need a critical value. Okay? The beauty of this is I just need to find it one time, because whatever it is over here, I'm just going to take the value over there and make it negative because it's symmetrical. Okay? So, nice little tattoo there. I don't know if I'd get that on my back. Maybe like, anyway. I guess I wouldn't get it. I definitely wouldn't get a tattoo right now. That'd be, okay. So I digress. So I have everything except the critical value. All right. So to determine the critical value, I've got to go to the T distribution table. Now, Jenna was on to something when she talked about degrees of freedom. There's two things I need when I go to the T distribution table to find a critical value. The first is degrees of freedom, which is a simple formula, n minus 1. Okay, so I have a sample size of 12. My degrees of freedom is 11 in this case. Alexa, do you remember what the second thing is I need?
I can try to figure it out.
Yep, I know you can.
You would have to take that degrees of freedom number and the level of significance and use it in the T distribution table.
Okay. And what do I want to do with that level of significance? Do I want to do anything special with it?
You want to use alpha half.
Roger that. Okay. So alpha half in this case, all I take is 0.05 and divide that by 2. And in this case, it'd be 0.025. Okay, so I'm going to remember those two things. I'm going to get my house in order before I go into the T distribution. Degrees of freedom 11. Alpha half is 0.025. All right, so I get that straight. And let me see. All right. Boom. Okay, now we have two T tables. They're actually the same. Pearson, just to give you a heads up, I don't know if I have the other one open. I actually do. This is on your Canvas. It's also in your book. So table E3. There might be a problem out of the 6 that has like degrees of freedom of 90. They're the same table. So you could use this table for this problem that we're working on. Okay. The degrees of freedom, the values at the top are the same. They just look different, but either road will get you there. I like this table because it's cleaner. This table lets me down once I get to like 40. Okay. On exam day, I will make sure you have both. You know the deal. I don't wake up in the morning trying to confuse you, although sometimes I do, and I apologize for that. Not on purpose. So, degrees of freedom, I'm going to go to this left column first, and I'm going to start, and I'm going to work my way down till I hit 11, and that's right there. And then I'm going to walk to the right, watching that top column here until I get to 0.025, and there I am, the intersection of those two values. And so the value above my cursor is 2.201. Got to remember that, 2.201. I'm going to get out of there. And let me get my stuff back up. Boom. Okay, so what is 2.201? 2.201 is my critical value. So it's positive over here, It's negative over here. Okay? So just to make this thing clear, super clear, just bear with me 2 seconds. I'm going to give myself some more space here. All right. Come back, baby. There we go. So I'm just going to make a little decision rule, which says that if my T-stat, I'm just going to abbreviate and give it a different color. If my T-stat is greater than 2.201, I'm going to reject the null. Because if my T-stat is greater than 2.201, I'm going to be out here in rejection land. Big sad face. Okay? Not for me, but somebody's getting rejected. And then at the same time, if my T-stat is less than negative 2.201, I'm going to do the same thing. I'm going to reject the null because I'll be out here. Okay? And if neither of those is true, I can't reject the null. I'll be in this white space somewhere. Okay? So, I'm not like playing games with you. Like maybe, man, every time I do stuff with Zoom, my stuff disappears. Okay, sorry. There might be a place where Pearson refers to a decision rule or something like that. The more I use decision rules, the more I actually like them because it helps me just match everything and make sure everything is in line. At the same time, I want to be clear. I definitely am not going to say, hey, Nick, what is step 5 of the critical value method? And, expect Nick to like spit that out verbatim. I just am not interested in that. I will, and I am interested in saying, hey, Nick, here's a problem. Tell me whether we reject or fail to reject the null hypothesis. To me, that's fair game. And hey, Nick, do it using the critical value method. So you see the difference. So I'm not on an exam or something like that. I'm not going to ask you to write a decision rule. I am going to ask you, hey, do you reject or fail to reject this thing? Okay. So writing a decision rule might actually be helpful for you to just make sure that you're getting this thing straight. Okay. So now we've got the decision rule. The big question is, what is our T statistic? Okay, so let's just go down the order here. And first things first, X bar. Well, wait a minute. How do we figure out what X bar is? So, Colin, how do I figure out what X bar is?
Is that when you add them up and divide them by each other?
Yeah. Divide them by what, do you think?
You divide by 12.
Yep.
All right.
So super. That's exactly what I'm going to do. Okay. We just haven't done it in a while, but we know how to do it. And when we do that, I'm communicating with the chicken in my mind. We get 112.85. That is our X bar. That's, just to be clear, these 12 values summed together divided by 12. All right. We know our mean is 120. And let's see. Jenna, how do we figure out what S is?
Is that was that sigma or? No,
So,
kidding. I don't know.
yeah, so that's sigma. Remember, S is the standard deviation of these numbers.
I do not remember the formula for that one, unfortunately.
Okay, that's all right. What do you think, Lauren? Do you remember how we determine that?
Do you just put them all in Excel again and just do standard deviation?
I knew you knew because last time I asked you, you knew. You remember? I'm serious, man. All right. Do I put a P or an S there?
P.
Exactly. I put an S. S for S. Okay. Because it is a sample. All right. And then what I put in parentheses is the array of wherever I have that in Excel. Okay. And I don't know. I guess Cameron probably knows the answer to this. I can probably start there and highlight the whole thing this way and put that array here. I don't know. I would rather just do it vertically and start from the top and do how I always do. So regardless, I got to put an array in here and that will return a number. And in this case, that number, the chicken tells me is 20.8. That's the number I get when I do the standard deviation .s for those. And then of course, at the end of this, I have the square root of 12. So that's my t-stat setup. When I compute all this carefully, I get the value of negative 1.19 as my t-stat. So that takes us through step 5. So Alexis, based on a t-stat of negative 1.19, do I reject the null hypothesis or do I fail to reject it?
You fail to reject it.
Okay. Why is that?
Because it is
Tell me where negative, go ahead. Tell me where what negative 1.19 is. Is negative 1.9 here?
no, it's more in the white area.
Yeah.
Yeah.
So it's not less than this and it's not
And it's
greater
not
than
great.
that. So you are correct. Alexis is correct. It falls in here, which is my do not reject. Okay. So as much as I might believe that it's changed from 120, I really don't have, my hypothesis test does not support that claim. All right. So the next action is keep working and kind of be quiet. All right. All right. Any questions on what we just did? Okay.
Yeah, well, I have a question.
Yes.
So every time that we have one of these problems for the what am I forgetting? I'm being stupid. For the S, are we gonna be given like those like samples where it says like for the 6 weeks? Are we gonna be given those to solve that?
I would be ready to do that. I wouldn't
Okay.
say that every time, but I would certainly, to me, that'd be the harder thing to do. And so I'd be ready to do that. Does that make sense?
Yep.
I mean, sometimes you might be given S, you might be given X bar, and sometimes you might have to compute it.
Okay.
So I'd be ready to compute it. Because then if it's given to you, you're like, oh, badass, man. That just saved me some time and some headache.
Oh, well, no, that's what I meant. I meant like we'd have to compute it. I'm sorry. I didn't mean like that you're just gonna give us the number. Yeah, sorry about that.
Yeah, it's okay. I would be ready to do it this way if I had to.
Oh, yeah, that's what I meant. Okay.
And you all are capable of doing that. You just got to brush up on, okay, how did we do this again? And if this still isn't clear to anybody out there, I can pull up Excel and just make it crystal clear. So if someone still doesn't get this or it doesn't come back, we can do that. Okay, just let me know. Nick, does that answer your question?
Yeah, sorry. I said it wrong. So
No worries. Okay. Other questions on what we just did? Okay. Let's go to the next one. What do I want to do here? I'm going to skip down. Okay. And I always hesitate doing this, but just so you're oriented, we have in this deck, and I will get you my notes on how to do the same problem that we just did with a two-tail p-value. But I'm going to skip down to doing it as a one-tail. So I'm actually skipping two problems. But when we do this type of problem, I'm going to address some key things. So I think once we're done with this one, you should be able to do any of them in the deck. All right. So get my pen back up, get rid of all this. I'm going to go a little faster because, at least in the first part, because up till about this step here, number 4, a lot of things are the same. But we do have a little bit of difference right off the bat, which is this terminology. Okay, so let's address that. So when we say has increased, okay, Matt, what kind of null and alternative are we looking at, do you think?
It's going to be less than or equal to for the null.
Okay, like this?
Yep.
Okay, super. All right. So again, what we think is that it's increased above 120. So we could do that first and park it there, and then do the opposite for the status quo, or vice versa. But we first have to disprove the status quo. All right. Picking up the pace. So that's step 1. Step 2 is our level of significance, 0.05. And our sample size, neither of those have changed. Step 3 is determine the test statistic and sampling distribution. Again, because we're in this situation where sigma is unknown, we know we're rolling with the T brothers, T stat and T distribution. Okay, and again, our T stat, the formula for that, I'm just going to write it over here this time, is X bar minus the mu over S, which we remember is the standard deviation for the sample, over the square root of n. Okay, so we've got all that ready to go. Collect the sample data. So now we're on step number 4. And let's see here. Collect the sample data. Well, we have that. Compute the value of the test statistic. Okay, and then same method. So to compute the value of the test statistic, we're going to need X bar. We add all these up as Colin stated, and we divide by 12. That gives us the X bar. Again, that doesn't change. So 112.85. Okay. To determine the standard deviation, we're going to do as Lauren expressed. We're going to take that S dev.s function in Excel. We're going to highlight the array, and that would return 20.8. That number is going to be different if you use a P, so you don't want to use the P because it's not a population, it's a sample. Okay, S, it all makes sense. All right, so we're going to have that number. We have the mu, which is 120. We have our sample size, which is 12. So when we put all that in here, we will have a T-stat. This is the same value of before, which is negative 1.19. Okay. So up to this point, oops, sorry. all of this is, when I say, has not changed, meaning from the previous problem that we did, that part has not changed. Obviously, if you do this problem for the first time, you probably want to move a little bit slower than I am right now. What I want to do is focus on this p-value thing. Okay. So to compute the p-value in this situation, we have to use Excel to do that. Now, so that's the first thing. We're going to use this formula. We're going to start typing this in. Let me just make sure I get, yeah. Okay. We're going to start typing this in, and Excel is going to give us a menu. So you guys know the deal. Once you start typing a function in an Excel, Excel tries to be smarter than you and start giving you options. You still got to be smarter than Excel and pick the right options. So it's going to give you options that look like this. It's going to ask you if you want to do this function. It's going to ask you if you want to use this function. And it's going to ask you if you want to use this function. Okay. So the key here is you've got to identify if you're doing a one or a two-tailed test. If you are doing a two-tailed test and a p-value method, then you would use this formula right here that's above my little squiggly line. That is why we have a 2T out here. Okay? That stands for two-tail. But we're not doing that right now, so we're not going to pick that right now. All right. Now, the next question is, okay, so we're doing a one tail, but which tail are we working in? Remember, that is dictated by the relationship of the proportion or population, the population mean or population proportion, the relationship of that symbol and this symbol right here. Okay. So if we have what we have, we are going to be working out here on the right tail. Okay. And if we did this with the critical value method and we established a rejection region and a non-rejection region, which we don't have to do under the p-value method. But the bottom line is our rejection region, we would have one for a one-tailed test, and it would be out here. The rest of this would be DNR. Okay. So we would choose this function because that RT doesn't stand for road and track. It stands for right tail. And if we were working in the left tail and we had the reverse of this, we would choose this top one. You notice that there's no left tail option. That is the default. So when you see this appear, it really stands for the left tail. But we're not going to use that right now because we're working in the right tail. We're going to use this RT. So that's what we're going to do here. Okay. So that's the first thing. All right, is to realize, because if we use the wrong function, we're going to enter some values, but we're going to get the wrong value that we need, which is the p-value. And that's the other thing, excuse me. All of this madness that we're doing is to determine what the p-value is. Okay, and we're still on step 4. Okay, so once we've decided which of these we need to use, Excel is going to ask us for X and then something else, which I'll get to in a minute. Be very, it's like that old Bugs Bunny cartoon. Be very, very careful. This X is not what you think it is. I'm going to put a little star here. What this X is referring to is the T-stat value. So don't try to put X bar in there. Don't do that. Don't put something else in there. Put the T value. Here's the other thing. This formula and none of these formulas will accept a negative value. Okay, so if this is a negative value, all you have to do is make it positive. Okay. All right. These two things are very important. Now, if you put a negative value in here and you put the other number here, Excel will give you an error. And if you're on your game, you can actually drill into the hyperlink and see, okay, what caused my error? And you can fight your way out of that. But if you don't want that kind of heartache, which I wouldn't think that anybody would, just remember, I can't put a negative value in here. Excel won't let me do that. Okay, so three key things. Number one, remember which tail you're dealing with, or if you're dealing with two tails, and make the appropriate function selection. That's the first thing. The second thing is don't get fooled by this X. Excel's going to ask you for an X. Remember, that's this value here, the T-stat. And then the third thing is don't put a negative value in there, put a positive one. The other value it's going to ask you for is super easy in comparison, and that's degrees of freedom. We already know that. That's 11. Okay, so for this problem, we're going to have tdist.rt because we're in the right tail. Our t-stat is negative 1.19, but we're going to enter 1.19 positive because Excel won't accept a negative number. We got our degrees of freedom. All that is going to return a p-value of 0.2588. Okay. Nope. I have my wrong sheet. I apologize. It's a different value. Sorry. It's 0.1295. Okay, that's our p-value. And by now, we're probably able to recognize, that's a pretty big p-value. Let me put my alpha over here just to compare it, because that's what I do here at the end. I have an alpha of 0.05. I have a p-value of 0.1295. This is a greater value than my alpha. And when that happens, regardless of what method you use and what works for you, if the p-value is lower than the alpha, we reject the null. Well, it's not. So I shouldn't be rejecting the null. If you like the alligator and the fish, is my alligator eating the fish? No. My alligator is eating the p-value. So if my alligator is not eating the fish, I'm not going to reject my null. So I would fail to reject this null hypothesis. Okay? So the tough terrain, I don't know if it's tough, it's tedious, is just, once you get over here, the p-value method, and making sure you select the right function and then enter the right values so that you can get that p-value. And once you get here, you'll know what to do. You'll know what to do. But the trick is getting here and not getting hung up about some of these technical pieces along the way. We skipped over a couple problems. So one of the other problems was a two-tail, and that's why I messed up this value. The only thing that's different is obviously the null and the alternative. And when we do the two-tail, we're going to use 2t. We still enter the same t-stat, and that's what gives us a different p-value. Okay? So if you can do this one right here, you can go back and do the other ones. All right? And they're not for turn-in or quote grade or anything like that, But as always, all reps matter. And when you get the time, I would encourage you to do those. I will provide you my notes so that you're not just doing something in isolation. You can check yourself. Questions on this? Questions on anything? Anything at all, big or small?
I mean, I had a question on the last one we just did.
Okay. What's up, Tim?
So you said for the two-tail, for the XL equation, you're just going to put dot R2T or?
Okay.
Okay, yeah, it's right there. Or it's 2T, not R.
Yeah. So for this problem that's on the board, Tim, just to be clear, we're going to use this one that has the red arrow next to it.
Mm-hmm.
If this was a two-tailed one, like this one right here, which is earlier in the deck, two-tail, then we would use that T.dist.2T. Okay. Which is that one right there. Does that answer your question?
Okay, I'll go with 1 second. Yeah, sorry. Someone was asking me a question off camera. Yeah, thank you.
Okay. All right. What else? Other questions, big or small?
Are we going to be able to view these slides? The only reason I ask is just so because I wanted to do the solution for the two-tail critical value one, or the one-tail critical value one.
Yeah. So when I will, as soon as we get off, I will post. You're talking about these, my answers, my notes. That doesn't, you can't even see that. It's the Bat Cave like shine.
I mean, I just mean so I can try and do it. That's all.
Yeah, I will post them when I get off the call tonight, and I'll do my little notify everybody that Canvas is updated. So they'll be on today's Canvas page. Nick, on today's Canvas page, you have the sterile version of what you're looking at. And when I say sterile, I mean nothing on it.
Nothing on it, right.
Okay.
Right.
And then what I'll do is post right underneath that. I call it the how-to, which is my notes. So you can work through it and then check yourself in that. Get some reps in that way.
Okay.
All right.
Thank you.
You bet. Other stuff, big or small? Anything?
So after like today's lesson, we should be able to do everything that's on Pearson, right?
Yes.
Okay.
Yes. With the exception if there's some technical difficulty that I missed, and this time I don't think I did. Like I said, there might be a t-test that you need to do where you need the table that goes up to 91. And just to double tap, I will throw that table in there as well on tonight's Canvas. It's on Canvas already, but so you don't have to go for an Easter egg hunt to find it, I'll throw it back in there again, just in case. I don't know for sure that you need it, but just in case, you got it there at your fingertips. Okay? Other questions? Okay, super. Great to see all you. And if I don't talk to you, have a great weekend. If you do need help, please reach out and we'll get you unstuck if that's necessary. As always, I'll hang around to clear the call. I'll post the video from tonight. I said I would post a couple other things. I will do those as well. And if I don't talk to you, have a great weekend.
Thank you.
Thank you.
Yeah, I just have a question real quick. Stupid question.
There are no stupid questions,
No,
Warrior.
It's because I already emailed you about it. Because I did a video, should I download it to Google Drive and submit it to you or email it to you, or how should I do that?
There's a number of ways you could do it. You could
It's
share it with me on
just like
Google
a
Drive.
yeah, it's just a video from my phone because I didn't do like I didn't like edit it or anything. It's just like a if that makes sense.
I had one person upload it to Canvas. I had another person. I haven't had anybody share it with me on Google Drive.
Oh, I was just no. The reason I asked that is because when you go to like submit something, I thought I was just gonna do it. I guess I can add it as an attachment if I just do it on my phone. I could just do it that way. It doesn't matter. I was just thinking if I like download it to Google Drive and then post it from my Google Drive, but I can just it. I'm sorry, stupid. Like I said.
Because because it's a video, I'm a lot less like, hey, it needs to be on Canvas kind of thing.
Yeah. Well, I'm just glad that you're not posting it like for everyone to see, because then I'd like go nuts. So I hate hearing myself on a camera. It's weird, but whatever. But I'm really sorry about not turning it in on Tuesday, and I understand. Like I said, if there's like a consequence or a D grade or anything, I understand that. So.
Well, I appreciate that. At this point, I think we just we should concentrate on getting it in. And I'm not going to give you a penalty for being late, so to speak. I think the main thing is that we see where you're at and your knowledge of the subject. And with that, if you do want to edit it, then I'd be okay with not getting it today. I'm kind of don't want you to lose sight of turning it in.
Of course, right.
What's that?
No, I just said you're right. Yeah.
So I'll leave it to you. I'm not hung up about that it's late. I know you got a lot of stuff going on.
Well, thankfully that the whole like craziness, and I don't mean to take your time up, but I know I told you did I tell you about my dad's house, and we were trying to get it to sell it and everything.
Right.
Well, in 3 days we actually sold it.
Oh wow.
So that was kind of like super fast timing because there was like 12 people who saw it. I'm so sorry. Can I answer the phone real quick?
Yeah, go ahead.
I don't know if my mom's. Oh, she's outside. I think she locked herself outside.
Well, go take care of that, Nick.
No, it's okay. No. Yeah, I'm sorry. Yeah, I gotta go. I'm so sorry.
Yeah.
She locked herself outside, so.
Yeah, go take care of your mom, man. We'll
All right.
catch up
Thank
later.
you again. I'll
All
talk
right,
to
you
you
bet.
soon, all right?
Take care.
All right, take care. Bye-bye.